For each of the following angles, determine the secant of theta, the cosecant of theta, and the cotangent of theta. Well, to figure out these trig functions at these angles, we need to know what they are. We need to know that the secant of an angle is the reciprocal of cosine. The cosecant of an angle is the reciprocal of sine. We take sine and we flip it. And the cotangent of an angle is the reciprocal of tangent. So, to find the secant of 30, to find the secant of 30 degrees, well, we need to say what is cosine of 30? What's cosine of 30? And we flip that. Well, cosine of 30 is square root of 3 over 2, so this is 2 over square roots of 3. Well, what's the sine of 30? Because we need to now figure out the cosecant of 30. Cosecant is the reciprocal of sine. So what's the sine of 30? The sine of 30 is a half, so when you flip a half, you get 2 over 1, which is 2. And finally, the cotangent of 30, we need to know, well, what's the tangent of 30? Well, the tangent of 30, if you have memorized it by now, the tangent of 30 is square root of 3 over 3. So this is 1 over square root of 3 over 3, and I want to flip that. So 3 over radical 3. So the key thing to figuring out the secant, cosecant, or cotangent of an angle, we need to know the cosine, sine, or tangent of the angle respectively, and then we just flip that value. Theta equals 5 pi over 3. We don't feel comfortable with radians, so let's get out of radians and back to degrees. We know there's 180 degrees in pi radians. 3 divided by 80 is 60. 5 times 60 is 300. So this is really 300 degrees. What is the secant of 300 degrees? Well, first of all, let's get a unit circle, and I'm going to do this over here. Let's get a unit circle. 300 degrees is in quadrant 4. What's my reference angle? Well, it's a pi over 3, which is a good indicator that it's a 60-degree reference angle. And in quadrant 4, we know that cosine is positive. The cosine is positive and sine and tangent are negative, so that means secant's going to be positive. So this is equal to 1 over the cosine of 60. What is the cosine of 60? The cosine of 60 is a half. So when I flip a half, I get 2 over 1, which is 2. The cosecant of 300, well, that's 1 over, we said our reference angle was 60, but I'm negative because I'm in quadrant 4. We're in quadrant 4, so secant's negative, which means that sine is negative, which means cosecant's negative. This is negative. Well, that's radical 3 over 2, so let's flip that. Negative 2 over radical 3. And cotangent, the cotangent of 300, well, that's 1 over tan, or you could say it's cosine over sine. You could use that identity if you want, but let's just go 1 over tan 60. But I'm negative because I'm in quadrant 4. Tan of 60 is square root of 3, so 1 over negative square roots of 3. And finally, theta equals negative 60 degrees. Well, if theta is negative 60 degrees, our reference angle is 60 degrees and we're in quadrant 4. So guess what? You don't have to do any more work because we already did that. We already did all this work right here. That's the answer. It's the same thing. So if theta is negative 60, we're done because we just did that for 5 pi over 3. Negative 60 degrees and 5 pi over 3 are actually the same angle. They're not the same angle. They are coterminal. They land at the terminal ray is the same. So the secant of negative 60 is 2, the cosecant of negative 60 is negative 2 over radical 3, and the cotangent of negative 60 is negative 1 over radical 3. The big idea that I need you to walk away with from this are these identities, knowing what secant is, knowing what cosecant is, and knowing what cotangent is. That's essential. Number 2, if pi over 2 is less than theta, which is less than pi, well, let's stop and decode what this means. That's 180 degrees, so half of that is 90 degrees. So theta is in quadrant 2. That's what we're trying to get from that piece of information there. Find the value of the 5 other trigonometric functions if sine of theta is 2/3. So I'm in quadrant 2. And the sine of my angle, it's not my theta, that's my theta. The sine of my angle is 2 over 3. So I can use the triangle that has an opposite of 2 and a hypotenuse of 3. How do I find that third side? Pythagorean theorem. Leg squared plus leg squared is hypotenuse squared. X squared plus 4 is 9. So x squared is 5. X equals the square root of 5. And you can put a square root of 5 here. However, I think this is a great idea to do. Notice that that x direction is negative. They were in the negative x direction, so I'm going to make that a negative square root of 5. That way, I don't need to think about who's positive and negative in quadrant 2. I can just go along and say, what's the cosine of theta? Well, the cosine of theta is adjacent over hypotenuse, negative radical 5 over 3. I don't need to think, it's already negative. And what's the tangent of theta? Well, the tangent of theta is TOA, opposite over adjacent, 2 over negative square roots of 5. So if you didn't put that there, you would have to recognize, oh wait, cosine is negative in quadrant 2, and that's fine. So if your triangle is ever in the negative direction on an axis, this is the negative x, this is the negative y direction, you can make the legs of your triangle negative. The hypotenuse is always positive, the legs are what become negative. Well, those are 2 of the other 5. What are the other 3? The other 3 are secant, cosecant, and cotangent. Well, what is secant? Secant is the reciprocal of cosine. So negative 3 over radical 5. Cosecant is the reciprocal of sine, 3 halves. Cotangent is the reciprocal of tangent, negative radical 5 over 2. Done. That's how we got the other 5, by using our original 3 that we've known and loved since Common Core geometry, and taking their reciprocal. Notice that cosine, secant are negative, tangent and cotangent are negative. Secant should already be positive. Cosecant should be positive because sine is positive. Explain why the cosecant of pi is undefined. Well, we're not comfortable with the cosecant function, and please don't say the CSC function, it's cosecant, it's an abbreviation. Why? Mathematicians are lazy. So the cosecant of pi is 1 over the sine of pi. We should be comfortable enough that pi radians is 180 degrees to not have to switch there. So on the unit circle, what point is that? That is the point negative 1, 0. Sine on my unit circle is my y value. So this is 1 over 0. That's why this is undefined. That's why it's undefined, because we end up dividing by 0. That's why it's undefined, because the sine of pi is 0. That's why cosecant is undefined, because sine of pi is 0. We say pi is not in the domain of cosecant. You cannot put pi into the cosecant function. Number 3, find the values of 1 plus the tangent of pi over 3 squared and secant of pi over 3 squared. What do you notice? Pi over 3 is one of those angles that you should almost memorize at this point. We know that pi radians is 180. 180 divided by 3 is 60 degrees. So we need to figure out what's the tangent of 60 degrees and what's the secant of 60 degrees, and then we'll see what these come out to be. Well, let's do tangent. We know tangent is sine over cosine. That's one way to do this. So the sine of 60 over the cosine of 60. Sine of 60 is radical 3 over 2. Cosine of 60 is a half. They're both divided by 2, so we get the square root of 3 over 1, which is the square root of 3. Secant of 60, hold on, secant is the reciprocal of, not sine, it's not the same letter, it's the opposite letter, cosine of 60. The cosine of 60 is a half, so I need to flip a half. When I flip a half, I get 2. The reciprocal of 1/2 is 2. So, let's do 1 plus the tan of pi over 3. 1 plus radical 3 squared is 1 plus 3 square root of 3 squared is 3, so this is 4. This expression has a value of 4. The secant of pi over 3, that's the secant of 60, that's 2. 2 squared is 4. What do we notice? They're equal. They are equal. We get to look at this more together tomorrow. We get to look at this more tomorrow because we'll see why these are equal. And does it only happen at pi over 3? I'll spoil the mystery a little and say this will always happen. 1 plus the tangent of an angle squared is always secant of that angle squared. We get to talk about that tomorrow in lesson 7. Number 5, we end on a nice note. Even though it's problem 5, this is probably the easiest problem in this entire exercise, in this entire problem set that we have. Find the following values from the given information. I want to know what the secant of theta is if the cosine of theta is 0.3. Well, if secant of theta is 3/10, I'm going to make that a fraction. What's the secant of theta? Well, it's the reciprocal of that. It's 10/3. Done. If the I want to find cosecant if sine is negative 0.5. If sine is negative 1/2. Well, if sine is negative 1/2, what's cosecant? Cosecant of theta is flip that. Negative 2. Done. What is the cotangent of theta if tan theta equals 10? Well, cotangent is the reciprocal of tangent. 1/10. Done. What's the sine of theta if cosecant of theta is negative 10 over 9? Well, I know cosecant is the reciprocal of sine, so sine is the reciprocal of cosecant. Just flip it again. Because this is the flip. I flip that to get cosecant, so to get back to sine, I'm going to flip it back again. Negative 9/10. Done. I know it was number 5, but it was probably the easiest problem in this problem set. That was the reciprocal trig functions. Hopefully you know that secant is 1 over cosine, cosecant is 1 over sine, and cotangent is the reciprocal of tangent. There's a reason why we call them the reciprocal trig functions, because to find their value, we take the reciprocal of their respective sine, cosine, or tangent that we know and love. See you tomorrow for the Pythagorean identity.